Hello everyone, and welcome to our webinar today, Practical IIoT Solutions for Manufacturing, exploring a variety of MQTT architectures and applications. We're glad you could join us here today. To introduce myself, I'm Travis Cox, the Co-Director of Sales Engineering at Inductive Automation, and I'm presenting and moderating today's webinar. I'll be introducing my co-presenters in just a minute. First, I'm going to give you a preview of the agenda for the next hour. We'll discuss some of the benefits and obstacles of IoT implementations for manufacturers, and we'll explain MQTT and some other common elements in effective IoT solutions. Then we'll look at 3 IoT solutions in particular based on real use cases of companies that are getting into Industry 4.0, OEMs that are providing services to remote machines, and corporate MES applications. We'll conclude with some more discussion and a recap, and then we'll spend some time answering your questions about what we discussed or about IoT in general. So if you have any questions as you're watching, please type them into the GoToWebinar questions area, and we'll answer as many as we can at the end. If we don't have time to answer all the questions, we'll be sure to follow up with you after the webinar. To give you a little background on Inductive Automation, we've been in business since 2003. In those 15 years, our Ignition software has been adopted by industrial organizations in nearly 100 countries for their HMI, SCADA, MES, and IIoT needs. Over 1,700 integrators have joined our integrator program. About 48% of Fortune 100 and 28% of Fortune 500 companies are using Ignition for their applications. Ignition is also used by thousands of other great companies and organizations in virtually every industry, from oil and gas, water, wastewater, food and beverage, government, transportation, packaging, and much, much more. Ignition is unique because it's the world's first truly universal industrial application platform that provides an integrated development environment for HMI, SCADA, MES, and IoT, and much more. It has an unlimited licensing model that gives you unlimited tags, screens, clients, projects, device connections, and more. It has cross-platform compatibility, so it can work on any operating system, both on the server and on the client side. It's built on IT standard technologies, leveraging SQL databases. It is a server-based model that has a very scalable server-client architecture. It's all web-based and web-managed. The designer is included and web-launched along with the clients. And Ignition is modular, so that as a platform, allows us to horizontally scale the platform as we go along, and allows you to pick and choose the functions that you require. And the development environment is a very rapid development environment, and the deployment is very quick and simple to get information out to people. So now let's get into today's content. So first I want to introduce our co-presenters. First we have Tom Hechtman. He is the founder and president of Sepasoft. For over 25 years, Tom has worked with manufacturers in diverse industries to implement production control and tracking systems. He leads the development of the Sepasoft MES module suite for Ignition and is on the board of directors of the Manufacturing Enterprise Solutions Association, or MESA. Second is Arlen Nipper. He is the president and CTO of Cirrus Link Solutions. Arlen has over 37 years of experience in the SCADA industry. His experience covers a broad range of technology, from the design and manufacturing of embedded computer systems to complete SCADA system infrastructure implementations for Fortune 100 oil and gas companies. Arlen is also the co-inventor of MQTT and has been involved in many of the activities that recently led to MQTT becoming a dominant IIoT messaging standard. Sepasoft and Cirrus Link are both strategic third-party module partners of Inductive Automation. And we're very pleased that we can have both of them here on the webinar today. So Tom and Arlen, would you mind please telling us a little bit more about yourself and your companies? Tom, I'm going to start with you.
Sure. We've developed modules to extend Ignition with OE, production control, plant floor, SPC, recipe management, web services, and some more. And being on the Ignition platform, we can focus just on that MES functionality, because the platform handles all the other stuff, the communications, database connectivity, designing Windows reports, all that kind of thing. And we get to capitalize on other things like MQTT provided by Cirrus Link. But we've been around for a while, incorporated in 2003. We have 600 plus, I've actually lost track, MES implementations, over 200 plus companies, multiple MES certified integrators. We're in many different industries. You can kind of say the ones we're not in a little bit easier. In water and wastewater, not so much, and oil and gas, not so much at this time. And all types of processes, whether it's batch processing, discrete control, or continuous process. And back to you, Travis.
All right, thank you, Tom. And now, Arlen, over to you.
Thanks, Travis. Well, as you can see here, as Travis mentioned, the entire Cirrus Link development team is pretty much focused on MQTT. So I would say that Cirrus Link is in the MQTT enablement business, if you will. And one of the things that's interesting to me is that, as you noted, Travis, I was the co-inventor of MQTT, and it was in conjunction with Andy Stanford Clark from IBM, and it was on a project for Phillips 66 pipeline. They had very high latency VSAT systems, but they wanted to take advantage of this new technology in 1998 called TCP/IP that very few people in the SCADA industry were using. So it was very interesting that over that 15-year period from 1998 until 5 years ago, although a lot of companies were starting to use MQTT, we still didn't see it used that much in industrial automation systems. And a large part of that, I will have to say, Travis, is down to the fact that Cirrus Link was able to partner with Inductive Automation, use the SDKs that you have to rapidly develop the modules that are now available for ignition that really let us go back to the roots of why MQTT was invented and really leverage its capability. And I would like to take the opportunity here. One of the things that we've done is created a standard called Sparkplug that has really helped us accelerate OEMs in being able to take process variables and publish those in a manner that everybody can understand and consume. That was 2.5 years ago. Here, just a couple of months ago, we've taken that specification and now we've contributed to the Eclipse Software Foundation. It's a new project called Eclipse Tahoe, and it will be managed by a very professional open source organization. So with that, Travis, I'll hand it back to you.
All right. Well, thank you, Arlen. And thank you, Tom, for being a part of the webinar here today. I'm glad we have such knowledgeable and experienced presenters here to talk about IoT, because it really is an important subject. By now, most everyone has heard about the industrial Internet of Things, and they know that it promises the ability to get far more data at far greater speeds and in far more efficient ways than what we can do today. But there are still a lot of manufacturers who don't understand exactly how they should implement IoT, or specifically where. And the three of us have a lot of experience, and hopefully we can shed some light on those questions here today with these real case studies. It's one thing to talk about the benefits of IoT, but when you get into the details of making it happen, you run into a number of practical challenges and concerns. These obstacles often slow down IoT projects, especially at the beginning, because they're looking at the entire project, and they can be stopped altogether. Some of these common obstacles are extremely high costs, especially when trying to convert a legacy or older infrastructure into a new infrastructure, maintenance challenges, security issues, a lack of IT infrastructure, legacy devices that are still in use, we call brownfield, no effective way to move data to a central location, separate control networks, and there are many other obstacles. So Arlen and Tom, I know you guys have a lot of experience with working with customers on these obstacles and how we can overcome them. Are there any other obstacles you would add to the list, or any comments on what we have here? Tom?
Yeah, I think, the brownfield devices, and actually we see a lot of recording values on paper, or spreadsheets, that type of thing. They just don't have the connectivity to the devices in the field, and the controls network is incomplete. So having a cost-effective way to address that is a major concern to people. Another concern, I think, is security in this day and age. So exposing that information out in a secure manner is another major concern.
And Arlen?
Well, Travis, I think the primary one, you hit the nail on the head, is that it's the scope of the project. I like to say, you can't eat the elephant in one setting, but you can eat it in small bites. And I think with the technology that we've got with Ignition Edge, with MQTT technologies, it lets us put together migration strategies with customers. And we try to engage by saying, let's just solve one problem. Ignition's cost effective. It's not going to cost it's going to be very cost effective. Let's just fix that problem. But being able to put together a strategy that says this is going to scale from this one solution across the enterprise and show how we can do that in a cost effective way. And I think one of the use case that I'm going to go through is going to show that very prevalently.
All right. So despite all of these obstacles, our goals here today is to show you that there are proven ways to build cost-effective enterprise IoT applications. Today we're going to look at 3 different architectures, which are all based on actual use cases from actual customers. We're going to show you what these systems were like previously, what the problem was that we're trying to solve, and of course, what they look like today. By moving to new architectures, these companies got more power out of their applications, got their enterprises more connected, and we're able to do a lot more with that data. And what all these solutions have in common is that they utilize the Ignition platform and the MQTT protocol. In particular, the spark plug specification that is the conduit, the glue that puts it all together. So for those of you who may not be that familiar with MQTT, I want to talk just quickly about the benefits. MQTT is the protocol that we use to build IoT solutions in Ignition. So why do we use MQTT? Why has it become the de facto standard messaging protocol for IoT? And it's really all because of the protocol itself and the benefits of that protocol. Now, Arlen, I'd say here that you're definitely the most qualified person to talk about the benefits of MQTT, as you are the co-inventor of that. So can you give us a little overview of MQTT and the benefits here?
Sure, Travis, thanks. So as I mentioned previously, MQTT was developed for mission-critical real-time pipeline control systems. And we had a lot of requirements that we had to meet. We knew that we wanted to eliminate polling, and we were using, basically aggregate of about 200 to 300 baud at each booster station that Phillips 66 had. So the first thing is that MQTT had to be super efficient. So first thing is a very low bandwidth. The second thing we knew is that if we're going to control a pipeline system, we need to have state awareness. No control engineer is going to let me put in an unstateful protocol that he might send a valve command. It might go open or it might not go open. So you can imagine, so Phillips 66 have been using MQTT on their 14,000 miles of pipeline. And so for 20 years now, they've known the state of 5,000 Allen Bradley PLCs, 1,200 flow computers, 500 truck terminal systems, and tank farm inventory systems. And they've known the state of those devices in real time. And then one of the things that we were talking about that Tom mentioned is security. And actually, again, I'll note that in 1998, there wasn't near the concern of cybersecurity or people hacking into systems. But I think the huge advantage is that we built MQTT on top of TCP/IP. And we did not implement any security scheme in the actual messaging transport. Had we done that in 1998, you probably wouldn't even have heard of MQTT today. But because it's built on top of TCP/IP, we get to leverage the latest security that your IT organization wants to apply to your, TCP/IP network. And then lastly, what's really become very compelling with the spark plug specification in conjunction with MQTT is the fact that now we can start talking about the edge of network devices or the actual native devices being a single source of truth for all of our tags. And that's very important. And again, we'll go through that in the use case that I've got.
All right. So, MQTT here really is an important part of these solutions that we're going to talk about. And by leveraging the MQTT protocol on the Ignition platform, we can be a complete citizen of being able to publish data from PLCs, to be able to be the broker, the message, the middleware piece, and the consumer of that data. So we have the ability to be all parts of that. Now, also note that there are a big ecosystem of partners that are supporting MQTT natively on their devices, from I/O that's out there to edge gateways that are doing conversions and more. And so there's a lot. MQTT has been widely adopted and is the de facto standard. And by leveraging that on these different kinds of devices, whether again it's specific hardware or with the Ignition platform, we can push the polling of these legacy devices out to the edge of the network, rather than trying to pull over the WAN or over the cloud. We push it close to the device as possible. And then we can make that data instantly accessible to the entire enterprise without straining bandwidth, because we're publishing the data by exception. And we're pushing that data up. So as Arlen said, the single source of truth is very, very important. So let's talk a little bit about why we should decouple applications from devices. When you've got PLCs and intelligent devices coupled to applications through proprietary protocols, it's a complicated setup, because there are applications that all the applications are able to interact with any connected device. And when you have multiple applications need the data, they either need to connect to the PLC directly, or we start turning SCADA into middleware, which isn't necessarily the right approach. So that leads to a lot of problems with resources, networks, security. Redundancy is poor, it's hard to maintain. Most of your data gets stuck out in the field, and it's just not an optimal architecture or solution. But if you have an open MQTT-enabled architecture, your applications are decoupled from endpoint devices, connecting through a broker in the middle. It's a cleaner, simpler setup. The data is bidirectional and stateful, so you're able to trust the data that you're getting from those edge devices. This type of architecture is more secure, it has better network utilization, and has a lot of other benefits, as Arlen mentioned earlier. So imagine a scenario where all of your PLCs and devices were simply just publishing the data to a broker, and many applications could consume that without having to know who that end device was, what their IP address, or what those tags were there. It's auto-discovered. They automatically pop into the applications. Another thing that these three solutions we're going to talk about have in common is that they make it possible to affordably leverage data from multiple sites. If, for example, you have 10 remote sites and you wanted to get OE downtime for those sites, it would be very expensive to install a full OE solution to each one of them. But if you had a way to bring data from your other sites up to a central system, that would be much more practical. We're going to show you architectures that allow you to do this in a cost-effective way. And that's really the key here, is to be able to start, as Arlen said, taking bites out of the elephant and getting ROI as you go along, and being able to slowly migrate over to a complete IoT infrastructure. Another common element you'll see in most of these use cases is edge gateways. Edge gateways are devices that help you bridge your legacy or brownfield devices to MQTT. And they're very important in these different brownfield scenarios. There are a lot of legacy devices out there with proprietary protocols. We need to push the polling out to the edge of the network and get that data transferred to MQTT and published up by exception, so we can take advantage of that information. By adding even a few edge gateways, or even just one, you can add a lot of value to your existing architecture. And you can add edge gateways at other sites to enable complete solutions for OE and other applications. The solutions we'll show you here all use Ignition Edge, but there are other edge gateways, as I mentioned, out there. Another great advantage of the Ignition platform is that the MES modules and MQTT modules are tightly integrated. Both Sepasoft and Cirrus Link have modified their modules so that they work together to help capture and share more data. So Tom, I know you've recently worked with Arlen and Cirrus Link on this, and using the Ignition platform, your modules are able to integrate very nicely together. Can you explain a little bit more about what you guys did?
Yeah, so with OEE and other MES tasks in general, it's vital to collect accurate data, without any gaps. So by gaps, what I mean is if there's an interruption in communication, and then that communication comes back up, do you have missing data for the time the communications was down, or does that get filled in? And if you don't have that accurate data, you're kind of running data or running your production in blind mode. So basically, garbage in will produce garbage out, and your return on investment of installing OEE or MES, won't be recognized. So the same with Ignition platform and being able to use that and the Cirrus Link is now we can solve that problem. And so we worked with Cirrus Link to do that. And Cirrus Link has a historical store and forward mode that if there is an interruption in communications anywhere along the way, that gets stored, and then when the connection comes back up, all that historical data is passed to us, and then we fill in the gaps and we have the accurate data.
All right.
Thanks, Travis.
Thank you, Tom. So I know we'll get to see an example of that here soon when you look at your use case there for a manufacturing customer. So let's get into the real crux of today's webinar, and that is the 3 IoT use cases that we want to cover. First, we're going to have Arlen talk about companies that are trying to get into and participate in Industry 4.0. How do we get started? What's the current landscape look like? And what are the ways that we can get quick wins? Then I'm going to talk about OEMs that are providing services to remotely troubleshoot their machines as a service to their customers. And then Tom's going to talk about a corporate MES application that, again, leverages that MQTT protocol. So first and foremost, over to you, Arlen, to talk about companies who are wanting to get into Industry 4.0.
Okay. Thank you, Travis. So for this customer use case, we've been working with this customer for approximately 3 years now. And, we worked with the executive that was basically in charge of taking this company into Industry 4.0. It was a very large manufacturing company with plants around the world. And the problem was they had a very tightly coupled architecture. And they figured that 80 to 90% of the machine data that they really needed for things like machine learning and analytics was being stranded out in the field. So we worked with them, we put together a migration strategy, and what we had to start with was very typical in that it was a manufacturing plant, and they had all of these specialty machines, whether the machine was intelligent itself or whether it had a PLC connected to it. It was connected to a very rigid polling engine. So again, the problem with protocols in and of themselves is that when you have a poll response protocol, there is an application that has to send a poll, has to parse the response, and once it's parsed that response, it kind of owns that data. So it's kind of hard to share. Well, then that went to an operational SCADA system, and that was tightly coupled to an MES system. But as you can see in this topology, it's very, very difficult to break those pieces apart. So with this tightly coupled architecture, register-based tags had no context. And let me explain that a little bit more, is that, very simply, if one of those machines had a Modbus PLC on it, that's great. Protocol A is Modbus. We bring a Modbus register in, it comes into operations, and now what do we have on our screen? We've got Modbus register 40,012, and it's a value of 36. Well, 36 what? Is that 36 feet? Is that 36 degrees C? Is that 36 gallons? So what do we do on every SCADA system that, from a legacy standpoint, we have to double-click on that tag, and we edit it, and we give it context. We say, oh, well, that's a raw value. It's 04095, and we need to scale it 0 to 100 somethings. And those somethings are going to be in degrees C. And here's the upper alarm limit and the lower alarm limit and the engineering ranges. So that's all context that we add to that tag manually. Now that operational SCADA system knows about that tag until it may change in the field. And then we've got to go over to the MES system and do the same thing. Now, the goal and the vision here was to be able to start leveraging things like machine learning on premise, was to leverage cloud services and to leverage the investment that their analytics team already had in things like Kafka feeding their Hadoop and Spark visualizations. So over the last 3 years, what that's migrated to is this type of an architecture. Oops. So in the solution, what we've got is those machines are still there. Those machines are very expensive, and no way are they going to go out and replace all those machines. But what's happened is that we've put edge devices like Ignition Edge, and the company also developed some edge of network devices for very proprietary machines, and they implemented MQTT Sparkplug as well using the Tahoe specification. And notice now that the machines are publishing information into an MQTT infrastructure. So now we're starting to see the advantages of decoupling, in that Ignition is still a primary SCADA system, but now anybody else can come in and subscribe to the same tags that are being published in real time. So Kafka, being an MQTT creature in and of itself, can subscribe to any or all of the tags that might be published off these machines. Now, with some of the cloud injector modules that Cirrus Link have developed to run on Ignition, we can take tags that are arriving in real time and publish them to either Azure IoT Hub and or into Kinesis. Now, in this particular use case, the customer streamed high fidelity data into Amazon's SageMaker product. And if you're not familiar with SageMaker, it's a very, very sophisticated tool. As you can imagine, Amazon's been doing this for a long time. And what it creates is a Lambda that is the machine learning model of what SageMaker has learned, and then you can deploy that Lambda on Amazon Cloud. But you still have to have the bandwidth and the cost of using that. So a new technology that Amazon has come out with, Greengrass Core, very analogous to the Azure Edge from Microsoft, Greengrass Core can run that Lambda that's been developed on premise. So now we've got kind of a closed loop cycle in high fidelity machine learning, creating a Lambda, with that being downloaded back into Amazon Greengrass. And then of course, we've got the Sepasoft modules that are already integrated in as well for MES, OEE, and track and trace. So from an Industry 4.0 standpoint, the customer was, is not looking for new technology just because it's new technology, but the ability to reduce waste and efficiencies by an order of magnitude. Now also remote factories now with just dropping an Ignition Edge. And so I want to go back to that point that Travis was making, is that, for a few $1,000s, a best-in-class embedded edge of network device and Ignition Edge, now a remote factory that might just have a few machines can start publishing information securely into the same infrastructure and start taking advantage of the machine learning and all the sophistication that they've got in the solution that they've got deployed today. Now, the final thing there is that from that remote factory, the unique thing about MQTT, as Travis was saying, is it's a remote originated connection. So that means that remote factory doesn't have to have any ports open to any of its machines that are publishing information. That also means that for connections to Azure IoT Hub and to Amazon Kinesis, those are outbound connections as well. So from a security model standpoint, from a performance standpoint, with high availability and redundancy, this has become a very, very good solution for, a slow migration from legacy poll response to much more modern event-based architecture, one machine at a time. So with that, Travis, I'll hand it back over to you.
All right, thank you. So let's take a look at our second use case here, and that is OEMs that are providing services to remotely troubleshoot machines. And I'm going to be covering this one here. So to kind of first introduce the problem, in that we had an OEM who manufactures a machine, of course, that they sell to customers. The machine has a PLC on board. It's all ready to go. And of course, the customer integrate that in their plant floor. Now, oftentimes what happened is that the customer is responsible at that point going forward for troubleshooting and for integrating that machine into their all their systems, their SCADA systems and whatnot. And a lot of times the customers lack a deep expertise to really troubleshoot the machines well, to understand when particular things go wrong and how to address those. Now the OEM, of course, knows how to do that. They're experts on their machines, but has had a huge challenge in being able to do that remotely. Often they would have to send technicians out on site, and once they had to send a technician out on site, that means we lost production and we lost money in that. Or the customer would send export data that they collected in their SCADA system to a CSV, send to the OEM, or the OEM is going to try at that point to sift through that data, understand what had actually happened. So it is historically been a very challenging thing for OEMs to really provide a good service to their customers, and being an augmenting, being a part of really diagnosing and troubleshooting and finding issues before they actually happen. So we've seen many OEMs who've tried to kind of do this in the old way, and the old way would be, from their cloud infrastructure or corporate infrastructure, they would create VPN connections to all the separate customers, and that required that at the customer site they had a VPN router that was installed, or had to work with the IT to get that set up. And of course, that would be different from customer A to customer B. And so with that, then they would have a system that would connect to the PLC at the customer location on their machine by knowing its IP address, and then defining all the tags and polling those tags, especially polling it over the WAN, which has a lot of issues, especially when there's high latency. There's a lot of bandwidth considerations. It's slow. All of this is slow. It's hard to maintain. It's not scalable. It's tough for the OEM to do this for all of their customers, because it requires a huge infrastructure for them and a lot of these kinds of connections. So this typically wasn't done. They may have done it here and there, but it's not a service that they would typically just straight up offer. It was a case-by-case basis. So by finding MQTT and leveraging MQTT, this OEM was able to actually achieve their dream of being able to remotely troubleshoot and remotely diagnose these machines. So what they would do is, with the machine that has the PLC there, they would also put a embedded PC with Ignition Edge to poll that PLC locally, and then it would already be pre-configured to connect up to their MQTT server in the cloud. So that edge would be connecting up. There's no connections down to the customer whatsoever. The customer's data is being pushed up securely to the cloud here. So those Ignition edges are pulling all those tags from the devices, pushing up to their MQTT server in the cloud in real time. So they're getting the real-time granular data that they are then, of course, using Ignition as a system to receive that data and historize it and be able to go through that information and provide a real service to their customers. So here, the real difference is that they don't have to have any connections to their customers whatsoever, and because the data is being published up by exception, and the single source of truth of the tags are at the customer location on that edge gateway, and so they don't have to even know. Those tags are just automatically discovered and published up, and they can start taking advantage of that information. So they've been able to drastically increase performance and be able to help customers be a part of that process to know what's going on with their machines in real time. And this is something that we see in the consumer space a lot. We buy a refrigerator now, and the refrigerator is connected up to that, to that company's cloud infrastructure, and we get push notifications when it's getting too hot, or we get push notifications when we run out of particular food inside the refrigerator. This concept is very widely known and done in IoT. Your car is connected. Everything's connected. And the idea here is that now these machines that you're buying can be connected, and you can leverage the expertise and skills of the OEMs to help make everything in your plant more effective. So let's now take a look at the last use case here, the third use case, which is going to be provided by Tom, looking at a corporate MES solution. So Tom?
Thanks, Travis. Yeah, so this was a large company, and they're running OE across many locations. And really putting in a server at each site just wasn't that practical for OEE. And it wasn't that practical because, you know, do you put in redundant servers in case the server on the site goes down, that you have a failover? What about the databases and the backup of the databases and how to handle a disaster recovery? Basically, the cost to implement goes way up. And it's just not really the paradigm moving forward. And, you know, there are situations where you need to have servers out on the plant floor for critical MES applications. But for something like OEE, where it's more passive and not critical, it's just not as practical. So we needed to have a centrally located server. Also the connection to the controller. So now if you put a centrally located server in and you're connecting to your field devices, now all of the stuff that Arlen and Travis have been talking about, where you've got polling going on and the bandwidth and all that kind of thing, is a problem. And if you lose that connection to one of those devices, now you've got the gap in your data that I talked about previously. So we needed to have a solution here that addressed these issues of putting the server in a central location. Okay, so this is the old way. They had GE devices out there, and they're talking to their machines. And as Arlen said, it doesn't make sense to, you know, spend a lot of money replacing your devices out there on the machines. You have to reintegrate it, reprogram it, all those things. It's just not practical. So it would require pulling to those devices to a central location. And like I mentioned, if you have gaps in communication, then if this is a timeline here, you're going to have gaps in your timeline and not get accurate data. Remote factory, again, you're going to be pulling to each device in that remote factory, or maybe you put a concentrator in there. I've actually seen some companies try to solve the gap problem and the remote factory problem, but it's like an incredible amount of hours to develop. Usually involves like purchasing a data broker PLC that handles all the data communications, having strict standards that they need to follow. Every time they add a machine, it's pretty involved. So the maintenance of it long term is expensive, plus the initial investment was expensive, versus a more plug and play out of the box solution. So looking at what the solution is, Arlen was talking about spark plug there. So putting in a device here that you have spark plug on each of these devices. The remote factory is running a edge and network device like Travis talked about there. And these all report by exception. When the value changes, they get pushed up to the MQTT servers, and that then gets communicated to Ignition and the OEE module in this case. So now our gaps are filled in. We're getting all of our data. So if we have a failure from machine run 1 anywhere along this link to Ignition, it will store it. And then when the connection comes back up, it will pass that through. So there's actually kind of like a contract. This machine with Ignition. That's separate contract from this machine to Ignition. So it verifies that the value got through. And if it didn't get through, it's going to store it and pass it to us later on. So that totally solves our issue, or the problem we were trying to solve of having the gaps in the data. Okay, so now I'm going to show a quick demo, real simple demo. It will just demonstrate this concept, and so you get a little better idea of what I'm talking about. So on my local machine here, I'm moving it around, I have a, this is going to represent the field device, or the PLC, and an edge gateway that's doing the polling with the PLC. And then when there's a value change, it will push it up to the MQT server, and then that will be read over on Ignition here, where MQTT engine's running, and then we have it into our OEE module. So the best way to show this, I think, is, and you can see this, the IP address. This one over here is actually up in the Amazon cloud. So we're running the OE in the Amazon cloud, and then this one's just on my local, on the left side is on my local system. So the best way to show this, I think, is just showing a timing chart. We'll show downtime events and a downtime table. So we're starting up here, and I'll put in a downtime reason, code 100. I think that's like an NT jam or something like that. So we see that show up in our downtime table here, and it shows up into our timing chart. So we see code 100 there in feed 1 jam. And I'll reset that. Okay, so that's all fine and good. But now I want to simulate an outage. And I can't unplug my network cable because you won't see my screen anymore. So instead, what I'm going to do is turn off the MQTT server in the Amazon cloud here. So it's not going to accept any more values. So this field device and this edge gateway, when it value changes, it's going to want a response from that server. Well, I shut it down, so it's not going to get the response, and it's going to store it. So we can immediately see that we're offline. So even though it's report by exception, we know it's offline right away. Now I'm going to put a different code in there, a couple different codes here. And we can see it's not updating now because we're offline. So normally, this would be a gap in our data. A couple there. You can see that that chart even updated. And the last data it had was it was running. So that's what it shows. Now I'm going to re-enable it, the server. Go back here. I went back online. And then we'll give it a minute. And there's our data. The two different codes, the 120 I typed in and the 130, it shows up in our downtime table. So that's a real simplified example, and we're just doing machine state and some counts here. But you really can have, what product code you're running, am I in production, complete control down here, and up in the Amazon cloud or wherever your central server is, can just be passive in collecting that data and being able to show it with zero gaps and getting accurate data. So with that, back to you, Travis.
All right. Well, thank you, Tom. So here to let's quickly recap, the main takeaways from the 3 solutions that we presented here today. First, you can decouple intelligent devices from applications with Ignition, and in particular with MQTT. With that protocol and the Ignition Edge, or again, if devices support MQTT natively, that allows to do that decouple and to have that information being sent up securely, published by exception, to leverage all the benefits there. We can bridge these old and new technologies by using edge gateways, and it can be very cost effective to simply put one of these in place. As we've kind of said a couple of times, you could put an embedded PC or a VM that runs Ignition Edge with unlimited tags, talking to all the controllers, publishing the information up, and now you can start taking advantage of it. For MES or for analytics, getting the information to the cloud, whatever it might be, you can start getting some wins off that data with not a whole lot of investment. MQTT-enabled Ignition architectures allow you to leverage that data and read those resources efficiently across multiple locations, multiple sites. The tight integration that you saw of MES and MQTT modules eliminate the problem of data gaps and make the solution simple and out of the box, and it's really important. MQTT being plug and play, it's all self-learning. That technology makes expanding your system easy and saves vast amounts of time. You don't have to know what those devices are, what tags exist. They automatically show up, and if there's UDT definitions or structures, they show up automatically as well. So imagine that's that MES solution that Tom just showed, where you did that proof of concept for one location, and then after you're done, you got to roll it out to 90 other locations. How hard is that rollout going to be? With MQTT and the plug-and-play nature of all this, with just putting the edge gateway at the site, that you could roll it out extremely fast. These solutions offer a practical migration strategy for your existing resources. By putting that gateway in to leverage that data, you're in the first step of transforming to that new architecture. And they allow you to leverage these analytics and machine learning systems that Azure and AWS have, and that helps us with turning our data into better information, increasing performance, and better decision making. So to summarize here and wrap up the presentation, I want to ask Arlen and Tom if they have any closing comments about building these practical IoT solutions. Tom, we'll start with you.
Okay. Yeah, you can kind of think of it as, Travis, you're mentioning multiple things besides MES that are communicating with these devices. And it's almost like competing for connections to the device itself. And some of these devices are smaller. They can't handle all those connections. So you either have to upgrade that device to handle more connections, or you use an alternative solution, and MQTT does that very nicely. And then also just implementing MES for an enterprise across multiple sites can be challenging and costly, But MQTT really helps simplify that implementation and keep the cost down.
All right, thank you, Arlen.
Yeah, Travis. Well, I think what we saw here as the common denominator around all of this, and it's really, that's one of the concepts of MQTT that are kind of hard to wrap your head around, especially if you've been doing SCADA for a long time. And we've got this mindset that, oh, it's a PLC, therefore we must poll, therefore we have a poll response protocol. Whereas what we're showing here is that if you can think of the decoupling advantages of MQTT, where you're publishing information that anybody in the enterprise might be interested in, to Tom's point. So MES is interested in some of it, operations are interested in it. We do a lot in oil and gas, where a flow computer is a very schizophrenic device where, operations wants all the real-time data, but, billing wants all of the ticket data. So this can be replicated across many different industries as far as what the advantages of being able to use Ignition as a platform, a tool, if you will. Kind of, it's your Swiss Army knife for all of this cool MQTT technology, and then being able to leverage the cloud solutions, if you will. I mean, if you think about Google Cloud Platform, Azure IoT Hub, AWS IoT, IBM Watson, SAP Leonardo, the common denominator across all of those cloud services is that they leverage MQTT technologies. So with that, back to you, Travis.
All right, so we're going to get to questions here very soon. There's a lot of good questions that have come in already. We're going to get to as many of these as we possibly can. We do hope you enjoyed today's presentation, and that it gives you a clear path to building IoT applications. If you want to learn more about our companies, of course, please visit our websites that you see here or call the numbers that are on the screen. I'd like to invite everyone watching to try Ignition for yourself. All of you saw today can be downloaded for free, and in a trial period, you can get proof of concepts up and running. The install takes a few minutes. There's a lot of good videos and help on how to get started. So why not try it today and give Ignition a shot. Next month, Inductive Automation is holding an annual Ignition Community Conference here in Folsom, California. Unfortunately, ICC is actually sold out. But don't worry, you can still buy a virtual ticket that gives you post-conference access to all the recorded sessions. I myself am giving a session on enterprise architectures. I'm participating in a panel discussion about open technologies, and we're also showing a live building of our new product. And coincidentally, Tom and Arlen are also both presenting sessions at ICC2 about their modules, along with many other knowledgeable leaders from the Ignition community. If you'd like a personalized demo of Ignition, just call the number you see here on the screen and talk to one of our helpful account executives. And so with that, let's get into the Q&A. As I said, there's a lot of good questions in here. And if we don't get to all of them, we will certainly follow up with you guys afterwards. Now, the first question here, Arlen, this is going to be geared towards you. There's actually a lot of questions on here. Kind of the predominant question. For industrial IoT applications, how does MQTT protocol compare to OPC UA? I know you get this question a lot, so I guess compare and contrast MQTT OPC UA, Arlen.
Okay, I will try to do that yet again. Well, in the context of brownfield, one of the things that I like to, the notion is that OPC UA will be around. It's a good protocol. There's nothing wrong with it, but it's fairly heavy. And in most implementations, if you have an OPC UA server, it's actually a polling engine. It's not OPC UA out to a device natively. It's actually a polling engine. It's talking Modbus or Allen Bradley or Siemens or any of these other protocols. So it's not OPC UA in that instance isn't helping you gain efficiencies. You still have an OPC UA server. It's hard for redundancy. That's got its tags, and again, it's not self-learning those tags. So in especially where we've got the capability of running Ignition Edge, or a lot of these OEMs that are putting Sparkplug on natively, they can actually publish the tag and all of its metrics with that tag. So that includes the tag name, the engineering units, the engineering high and low ranges, and most importantly, for like for OEE and MES, the timestamp travels with the tag. And especially in things like leak detection for our oil and gas customers, the timestamp flows with the tag. So it's really scales of economy. A lot of what we do was remote oriented. It uses VSAT, it uses cellular, it uses spread spectrum radios. You don't have to have any ports open. That's why the cloud solution providers are using MQTT so predominantly, is that they don't have to reach into the enterprise. It's an outbound connection. So I try not to get into, there's right places to use OPC UA and there's right places to use MQTT. I just think that with the Sparkplug specification, we've added the context that was required. And from there, everybody are learning about MQTT with the overall community.
All right, thank you. Now, there's a lot of questions in here about what SP represented on those diagrams. SP was representing of the Sparkplug specification for MQTT. MQTT itself the payload is agnostic. There is no defined payload format, in the actual protocol. Now, in our industry, of course, we need to have an accepted payload format that's versatile, it's flexible, that all the parties understand, so that we could easily have that plug and play, that auto generation of those tags. And so that's what Sparkplug specification is. It's really the glue or the conduit that makes all of this possible. And there, of course, Ignition communicates with MQTT with Sparkplug with those modules that provided by Cirrus Link. And there are a huge ecosystem of partners, companies like Moxa, Opto22, Hilscher, Advantech, and many, many others that are Easy Automation and many others that are speaking Sparkplug natively on their devices. And so that's their ultimate goal, right? We live in the brownfield world. We have to get legacy PLCs to MQTT. That's what edge gateways are important for that transition. But when you have the architecture in place, when you purchase new equipment, they're going to speak MQTT, and it'll be a complete plug and play in your infrastructure. So there's a question here, Tom, this is going to be for you. In the OE and MES is run in the central location that you showed. Can the remote site see their slice of the pie without looking at other locations? Kind of a plan global by corporate, but act and monitor local by each plant, philosophy.
Yeah, you sure can. Because it's on Ignition, if you have a central server, you can break that up into different projects or security groups, and then those plants can then open up a client to view into that plant's information. The other alternative is put down a server in that plant as well. And we're actually currently in development on having these plants talk together on the Ignition gateway network between them. So synchronizing schedules, synchronizing production data, and that will definitely get you into that functionality as well.
Okay, so this question is going to kind of, both you, Arlen, and myself, we can kind of answer this together. It looks like MQTT is primarily for live data. What is the best practice for central storage of historical data to be accessible to multiple enterprise applications? or does every application store duplicate copies of the information pulled from the broker? So I guess first, Arlen, over to you to see if your response to that question.
Well, that is a very good question, and if you noticed in there, you know, with the example that I gave from Kafka NiFi to OSI Pi to the historian that's built into Ignition, all three of those could be historians for the information that's being published from MQTT. If you look at it from an edge of network device, as Tom was pointing out there, the edge device, I wouldn't say that it's going to be the source of all history. You know, it's a constrained device that's out there. So we're making sure that somebody is a primary application that would subscribe to those tags and put them into history. Now, whether that's going to the cloud, to like an S3 data lake, or whether that's going to OSI Pi or going to the SQL historian in Ignition, is really a customer by customer decision.
Yeah, and so my part of the answer to that question is that different kinds of applications are going to utilize that data differently, and they may not necessarily store it historically. As an example, ERP probably just wants at the end of the production, what was produced, what was that count, and what were some of the information relating to that production run. And it's going to store it in its particular way, but it's not necessarily time series historical data that a historian would actually work with. So certainly there's going to be different ways to utilize that data, and different applications probably will have duplicate copies of some of that data that's there. But there is the potential of, when we're getting information to the cloud into these different data lakes, that they could also work with MQTT, and there can be exchanging of historical data through that architecture. That we are looking down the road of leveraging MQTT for information like that, as well as to be able to commission devices, to be able to send down potentially PLC programs or different configurations that device is actually going to need. I know, Arlen, that you've been working with edge device companies on this in particular, and there is a bright future with being able to do that. You want to comment?
Yes. Yeah, and they're looking at Ignition. I mean, one of the as you can imagine, Travis, the huge attraction to running Ignition Edge on all of these different devices is that you've got the same software and the same programming tools and the same setup for multiple different devices. So it could be Ignition Edge running on a Cisco router, on a Moxa device, on a FreeWave radio, on a Dell Edge, on an HP Edge. But they're all using Ignition Edge so that they all look the same, they're all managed the same, and we still get to use the tools that everybody's familiar with from Ignition, the tag browser, the way that you define your tags, the way that you do your scaling, the way that you do your deadbanding is common across all of your edge of network devices. Okay.
There's a question here that it says, how is the edge device connected to the PLC? Are there possibilities of the edge device failing? So in the brownfield arena, certainly these legacy polling protocols that these PLCs support, these proprietary protocols, that device itself is not going to speak MQTT natively. So edge devices or edge gateways are very important in being able to migrate that information over. So the idea is that you put it on an embedded PC or some machine. It could also be on a switch or a router or a radio or many other kind of devices that have fog computing abilities. I know that we are working, with companies like Moxa and Cisco and others and FreeWave to do that. And so the idea is that once you have the software there on that device, it's going to communicate to that PLC like your SCADA system would normally. It's going to poll that PLC. But at that point, it's all local, right next to the PLC, and it would then publish that information to the broker, wherever it happens to be by exception. So we've transformed that now to, so you can kind of think of a thin layer, right in front of that PLC that's going to migrate that information over in the brownfield. Now in the greenfield arena, these devices will speak it natively. So it becomes very plug and play and very simple, as I mentioned before. So yes, there is a possibility of an edge device, an edge gateway failing. And in particular with Ignition at Edge, we support redundancy. We could have two of those running. But a lot of times you get industrialized hardware. That hardware is in the cabinet with the PLC. It's very reliable and can work for a long period of time. So I don't know, Arlen, if you want to have any additional comments to that.
Well, that is how do they do it? I mean, if you're familiar with Ignition and they're all of the protocol drivers that Ignition have already in their gateway, then that's what you get on the edge. So all your Allen Bradley protocols, your Modbus protocols, your Siemens protocols, Cirrus Link are developing oil and gas protocols for legacy flow computer devices. So all of those will be available. Those are out on the edge. Those are configured. And then from there, as Travis was saying, everything is MQTT up. And we can, we have lots and lots of use cases from Phillips 66 onwards for the fact that they've still got legacy edge of network devices that have been out in the field for 20 years.
All right. Well, unfortunately, we are at the end of the hour here, and we didn't get to all the questions there, so we sincerely apologize, but we will follow up with all these questions afterwards. We thank you very much for watching the webinar today. And if you'd like to stay informed about our upcoming webinars and events, follow us on Twitter, LinkedIn, or Facebook. You can also subscribe to our weekly newsfeed on our website. Again, thanks for coming, and have a great day.